Good afternoon, everyone. Can you hear me? Okay. So I am Sasidhar. I work as a data scientist in a financial services firm. Today I am going to talk about Python packaging. So, how many of you here have created a Python package distribution and published to PyPy? Oh, quite a few. What tools you have used it? Sir, tools. What tools you have used it? Setup tools. Okay. Yeah. I think that is a famous tool, right? I think something has changed over the years, which I think is created this ecosystem, or the ecosystem has become much better now. And what we are going to do today is I am going to cover how this has evolved over a period of time and what are the various tools and then how they really compare on these different features. And finally, we will do a quick demo on one of the latest and modern tool called PDM. I mean, PDM I have just chosen it only to really represent something, but does not mean this is the better. There are a lot of other tools and they have different type of capabilities that we can see as we go through. So, let us get an understanding of what is Python package distribution, right? So there are two types of Python packaging. One is packaging projects and packaging applications. Packaging projects is like you have a code that you want to give it to someone, they want to use it in their import it and then they want to use it. That's where you create a Python project. But application is you develop some application which you want to bundle it and give it to the end user. Probably end user may not be very well versed with the Python, but he want to just use the application. But in today, I am going to cover more on the Python projects, not on the applications. There are different tools for the applications, but I am not going to cover that. So, but what is Python packaging? So, it's just the process of creating a Python project so that it can be easily installed and used by the others, as simple as that. And what is involved in creating a Python project? You organize your code into modules, like functions, packages and all, and write some configuration which is required by the tool to understand and then package your code, and finally create source, archives or the wheel distributions. This is the very high level what really happens when you create a Python package. But what is that you need to consider when you create a Python package? Like, which are the users that are going to use your package? What kind of hardware that you are going to install this package? And is it a single user or multiple users? No, depends. So these are the considerations that you really consider when you really create the package. So at the end, packaging is all about target environment and deployment experience. Okay. So there is a group called Python Packaging Authority, PyPA. So which is is a working group, is responsible or maintains the core software projects used in Python packaging, right? So these are some of the goals that they have laid down. I think this has changed over a period of time. This is the latest one if you really go to their site and then look at it. So easy to use, it's provide easy to use software distribution, infrastructure that is also fast, reliable and reasonably secure. The word reasonably secure may be tricky. I think people say why reasonably secure, it's not 100% secure. But actually there is a lot of legacy packages are there in Python. It's difficult to really have the complete, a security for all of them. That's why they define. So to be realistic, it's reasonably secure. And they are working towards a meta packaging system. I'll go through, but when you get to the examples, you will understand a little bit of what is this. Clearly delineates the phases of distribution. There are multiple phases of this whole preparation of this whole package, and then you clearly delineate these phases and allows for multiple interacting tools. I think it's very important. They are not asking you to have a monolithic tool, one tool, but multiple interacting tools. And also they are encouraging to use alternative build systems. There is no one build system. I think you can use multiple alternate build systems also, and which is called as a meta build system. I think these are some of the goals or guidelines that has been laid by Python Packaging Authority. Okay, so this is all the core projects that they really maintain. PIP, I think everybody without PIP, nobody can really survive. I think all of the people might have used the PIP. Setup tools is a Python backend, build backend. Twine, which is used to interact with the PyPI. If you want to upload some of them to PyPI and interact with it, that is a Twine. Virtual N, which is the virtual creation of virtual environments. Wheel is official binary distribution for Python packaging, and then build is the uh, built front end. Basically, it's a front end. So front end and back end is like back end is responsible to just create the like wheels and source RSI. So front end is we will call the back end and also do the validations and everything. That is the difference between front end and the back end of these builds. So let's quickly look at how this is evolved over a period of time, right? So 1991 is when we created the first version of that software, and then it took almost 9 years to have one utility which is called dist utils. I think a lot of you might be really using it earlier, and if you prepared the packages. So and then somebody realized that okay, tool is not enough, but you need a repository. So Richard Jones, an Australian developer, he came up with the proposal for PyPI, and it was operational in 2003. And Philip Ebe, who is like proposed this setup tools in 2004. So now we have the repository. You have some tools that is really to publish the packages and all of them. Then it really came how people are going to use, make easy for them to really install these things. PIP came in 2008, and then by Ian Biking. And then there is a format. I think I don't know whether before wheels there was another format that is been there. Anybody know which is the other format? Eggs, yeah, I think eggs. Wherever you say the reference was Python eggs, right? So I think now nobody uses the Python eggs. All of them are replaced with another wheels. And then wheels was proposed by Daniel Halt in 2013. So there are PEPs I mentioned here. These are, if you don't know what is a PEP, is Python enhancement proposal. So every feature that we really implement in Python has been clearly documented in a PEP, reviewed and then agreed by this one before it gets implemented in the real software. So and then now we have all these tools available, systems are there and all, but I think always everybody like say that Python packaging had issues. Like all of this that is at least the perception. So now 2016 PEP 518, which is a pyproject.toml. So this is primarily to really take out, I think if you take setup.py, in the setup.py you import setup tools and then you do it, right? So it's like a catch-22. Unless you really run that, you don't know which version of that, and if you want to change the version of the, like a different setup tools version, you cannot do while you already imported and working on it. So I think pyproject.toml is to segregate that information and put whatever is required for build, and then you also clearly take out your build process, from your project, this one. So in 2023, Python 3.12, dist utils is removed. It's no more there. And then we are here in PyCon India 2024. So let's quickly look at what is the life cycle of this whole, like packaging, and also what are the different stages or things are involved, so that this is a reference, so that we can all, when you put all the tools, frameworks, we can compare with this, right? So I mean, if I want to develop something, first thing I want to choose a Python version. So once you decide a Python version, you have to tools to manage the Python, different versions of the Python. And once you have the Python, then you need to go and create a virtual environment where you really segregate all what are the packages required for your project. You go to install it, and then it really comes with package management. Package management is like pip is only installing the packages, but there are a lot of dependencies between the packages that you really use in project. So you need something to resolve the dependencies also, which is package management. Now we have everything ready. You really develop. You have created your Python version installed. Environment is created. Install the packages that you really want to like use it. Now the next step is to build. There is a package building, and then the output of this is source sources or the wheel distribution. And then once you have this ready, then you have to test your package, whatever that you do. There are CI/CD tools, like tools like test automation, Tox and Nox tools are there, which will take out your package, install it in a separate virtual environment, test everything is going to be okay. If it really works fine, then the next step is to publish to the PyPI. So that is package publishing. So this is the whole life cycle that you keep repeating, and then you really work on your project again. New libraries keep coming and develop and do it. So I think these are the Python version management, environment management, package building, package publishing, and package management. These are all the different things that let us see. Okay, before we go to the tools, let us understand a little bit on source distribution and the wheels distribution. So source distribution is like source files plus the metadata. Metadata about all of your project, which is in generally a tar.gz format. And build distribution is a source files built into a form that is ready to be installed on the system. Why do you need wheels? Why can't we really go and use the source distribution itself? Yeah, there are some dependencies. Absolutely, there are dependencies. Second thing is, I mean, there are millions of downloads really happening here, right? I think each time you really download a package, source distribution means if there is anything that is really required, you have to prepare the wheel package locally in your laptop and then finally install it. Rather, if you have a wheel distribution directly available in PyPI, you download it and install it, it becomes very fast. And like I think even the size of the wheel also is very, very important. There are a lot of projects I have seen people are trying to optimize the size of the wheel so that it can be easily installed and installed into the projects. Okay. So now take some few examples. Requests, which is a pure Python. If you look at, there are two distributions here: source distribution and the build distribution. Both of them are there here. And then there is only one build distribution with naming convention as none, any, and all kind of things, right? So basically, the pure Python, you don't have any other dependencies. So it means that it is applicable for all the platforms, like it's a Windows, Mac or Linux and everything, and also it's like there is no architectures really involved here. Processor could be anything. There is no differentiation as such. But if you take pandas, I think a lot of people that use for their data analysis, it has C dependencies and all. And you see there are so many wheels that have been really published here. So it means for each operating system and each architecture of the processor, you need to create a wheel and publish it. But it may be a little liquid from the maintainer who really really publish all these packages. But it is really easy for the person who is really consuming these packages, right? So they can directly install the wheel and then so let's look at this, what happens when you really do the install from a wheel. We just okay, pip install particular library like request here. It will download the library also along with all the dependencies in a wheel format and finally creates it. This is very easy and fast. But look at this particular library, WSGI. They don't have any binary distribution, they have build distributions. They only have the source distribution. So now what happens when a source distribution alone is there? You download this, you look at the steps here, I think what is really happening, it takes and then it builds a like binary or build distribution here and then finally installs it. So it means if it is only source distribution is available, then it will take that, build the wheel locally and then install it. It will take time. And not only takes time, but it needs all the dependencies. If you have a C compiler is required to be there and all of them are required. I mean, at least the other talk people are telling TALib, one of the talk, it's very difficult to really install that because the dependencies are there, and then he was really hoping in the workshop, if this gets installed, I'm all done. I think the remaining workshop will really go faster. That is what is his overall thing. Means like that is kind of dependencies are there, but wheels are there. This is all the operating systems are there and all the platforms are there. You can download and install it. So let's look at what is this wheel all about, right? When you're talking about wheels. So if wheel is nothing but just a zip file, within which there are things that are being packaged. Zip file, wheel is a zip file, but the specification of the wheel is how to prepare this zip file is what is the specification, right? So look at, there are two directories in this, request and then the request with version and dist info. So the request will have all the code that you really have, and the dist info will have all the files. License, metadata, wheel, wheel means like which version of the wheel that is there and then what is the format, and then metadata about the metadata of the project. License is all required. If you don't have a license for your published package, please make sure you have a license. And then there is a record. Record is like what, when you really install it, what are the different things that have been installed with that. But this is the wheel package before installation. Let's understand what happens when you install a package, right? The same package when you install it, if you go to the directories, there are two directories here. There is a request directory, you have all these files, and then there is a dist info directory, right? That info directory, all these files. And then it also writes something like install, so that you know which installer is used to install this package. And there is a called as requested. Requested is like to differentiate the packages between what is requested and what is a dependent package, right? So when I really install this request, I only requested request package, but there are other dependencies which got installed. You will not see this requested file for that. Okay. So this is the structure or whatever is there inside the wheels. And now let's get into a little bit of what is the project structure or directory structure when you really create this particular package, right? So typically this is what I think you have package, and then you have all these files and then your source code and all of them. But there are two important configuration files are there. When I said two important, one is setup.py or the project pyproject.toml. So setup.py is still supported. It is not that like we have to really take it out, but they strongly recommended to move it to pyproject.toml rather than the setup.py. So what is that? What is this configuration file really contains? It contains the metadata and all the dependencies that is required, and other attributes, whatever, like if you are some command line entry points and all of them are, those things are going to be there in this. So let us look at anatomy of this, anatomy of this project.toml file, right? So it has multiple sessions. I think toml is Tom's minimal, obviously that is a format similar like JSON and YAML and all of them, but it is very close to the structure. And this is there is like a section, and then the attributes will be there. So now if you look at, there will be a build section. I think they have defined in all these steps clearly what sessions to be there and what is mandatory, what is optional. So when I highlight it with a red color here, it means that these attributes are mandatory for build system. So in setup.py, you are having that setup tools imported directly, but in the pyproject.toml, what you are doing is you are trying to define what build system I am really going to use it here, and it has two attributes, requires and build backend. Requires is nothing but which library or the backend that you are really using it, and then what is the build backend, the API that you are going to use it. So from if you look at all these different examples here, you can mention which library, and also you can mention which library of what kind of version. Setup tools greater than or equals to 61.0, or flit core is greater than or equals 3.4. I can even mention which exact version that I want to use it. So these are the different alternate build systems is what I was saying, meta build system. These are different build systems that you can really use it. You can configure what are the build system you want it. Okay, and the important one is the project metadata, right? These are all the different things that you can really put inside that. Name, version is important, version is a mandatory, but the remaining all of them are optional, but it is strongly recommended to provide license, like readme and like authors and all of the information. So if you look at it, the name, authors are there, description, readme, requires Python, it will tell us that this project needs a version of Python greater than or equals to 3.8. Keywords for searching purpose, license is again what license, classifiers again, if you look at any of the package published in PyPI, you look at all these classifiers, everything is available to appear to you also, it is all searching purpose. And dependencies, I think this is where you say that these are all the dependencies which is required by my project. All these libraries, again the same naming convention, you can use exact version, or you don't have the version, latest version gets installed. So there is one more, version is mentioned as dynamic here. So in this pyproject.toml, you have some of them are static, you cannot change them. But dynamic is something which you cannot, runtime you can change it, because versions keeps changing of whatever you really publish, right? So this keeps changing as you really build these packages. So it is you are telling that build this one, saying that this is a dynamic attribute, and then this can get changed during the build. And optional dependencies are dev dependencies. You can always have these are separately tracked rather than your project dependencies. Optional are some things required for your documentation to build and things like that. Dev dependencies are your testing libraries and all of them. And this gives you some of the entry points. Entry points are like if you are building a like a CLI command line tool, it will tell you when you really import the package, run the package, like python-m and then give the package name, it will really directly execute these things. And these are all, you don't have to really manually write all these things. I think you can really put which function to really execute package and function, and it automatically picks up from here. There are three different type of entry points. One is for the command line tools, CLI, and the second one is for GUI, and third one is actually kind of a plugins. Something that you want to change the version, you can create a plugin that can automatically change the version, it becomes a plugin. And anything that is tool specific, like there are multiple tools are there, these are all tool.tool name, and then you can give those specifications. In this particular example, I am giving for PDM, tool.pdm.dev dependencies is the section under which I am giving all these different things, linters and what testing libraries that I want to use, and then docs. So I think it's important to really create this pyproject.yaml file, and then that is what all the configuration is going to be stored. Okay, let's look at the tools landscape. I think if you look at this whole like Venn diagram here, the tools outer circle, whatever are there, are the ones which are very specific purpose tools, like only for that particular purpose. I mean, if you look at pip is used only to install the packages, but whereas virtual and VNV is just to create the virtual environment. But the tools within the center can do more than one of these things, like either package management, Python version management, environment management, things like that, right? So there are something in center like Rai and PyFlow. They can do all the activities of whatever is mentioned in the Venn diagram. But some of them do a little bit more. So let us look at a comparison of what these different things are there, right? So Flit can do building packages and publishing a package. Poetry is like, except the Python version management, you can do all of them. PDM, actually in fact, I think the latest version do have even Python version management. All of them it can really do. Hatch, package management is not there, remaining everything is there. Ray is like full-fledged, everything is there. So how do these tools really play across different features? Let us look at a little bit on some of these, right? I think we look at, these are some of the features. Actually, this is picked up from one of the other talk called Annalena. I think she has done a detailed talk about comparison of other tools. If you are interested, you can go and look at it. Does the tool manage the dependencies? I think it's very, very important. And does it resolve to lock on dependencies? So what is lock or like lock the dependencies? So I mean, the developer who really creates an environment, sometimes if another developer try to create the same environment, it's not reproducible. So this lock will give you an option where all these packages installed in an environment are clearly tracked, so that any other developer who is really working on the project can really like replicate the same environment. Is there is a clean build workflow, and then does it allow to use plugins? I think plugins, some of them will support, some of them don't support it. Does it support PEP 650 editable installs? What is an editable install? Editable install is like when you are really developing a package, when you do editable install, it will not really take these files and then put it into the site packages, but it will give you a link, like soft link to this files, whichever you are building it, so that you don't have to rebuild and deploy. When you change the files, automatically you can really test your package. And does it support PEP 21 project metadata? I think Poetry is the one which is, they have their own metadata, they don't take it from project metadata, but all other tools do support it. Okay, so now I just wanted to see where we really stand with respect to what the packages that we have in PyPI, right? So I took a stab, maybe in somewhere in mid of August, I went to PyPI and then looked at all the packages, like what metadata. There are 562K published packages are there, out of which 54K published, the packages are with a GitHub repo. I mean, there are many of them, they don't even have a GitHub repo, then we don't know what is their build system they are using to really find out. So wherever there is a GitHub repo, I took all of them, and then 48K unique repos are there in the total thing, and then try to figure it out what build system each this Python project is really using. I just plotted it here so that you get an idea where do we stand with respect to today. Actually 40% of them, they don't have any, I mean, they're not using pyproject.yaml, means they are using the setup.py and other kind of modes. Poetry is the highest, I guess 24% of them are the Poetry. And we have invalid repos. I think some of the GitHub repos, even though present is there, I can't do anything with them. Setup tools is the next highest one, 7.28. Hatching is like, like hatch, basically it's 3.55, and then no build backend. I think even though there is some pyproject.yaml is there is no build backend mentioned inside that. Flit PDM, there are other things are there, like all these things are very less percentage. So actually what I figured out when I really doing this analysis is that like a lot of packages have been outdated, means like they have been really there in the PyPI, but nobody is really updating and doing anything with them. So probably if you are doing testing, don't use PyPI directly. There is a test PyPI is there. Please go and publish your package to test PI, not directly to the PyPI, right? So PyPI is like a production, test PI is for whatever that you want to really test it. At least you can manage and make it clean. So as I mentioned, setup.py is not retired or is not that you should not be using it, but there is something is restricted not to use, right? You don't earlier the way that we really create the builds is setup, right, directly run the setup.py with all these arguments so that it will really do whatever is required for you. But that is not encouraged and it is been actually like deprecated now. So I think there is each one of them there is a alternate command python-m build is you have to use it now to really build the package, but don't use it run the setup.py directly with the arguments here. Similarly, for they are recommending pytest or tox or nox to really use it rather than setup.py. Pip install -e is the editable install. Wine upload is to really upload it, and wine check is to check whether everything is really okay or not okay. Tox and nox are the automation environments. Okay, so now I have a quick demo of this. Let me play that video. Okay, so PDM is one of the tool. I just chosen it to really demonstrate what really happens. I think all of them, many of them really have all these commands. So that is one tool caters to lot many things that you do it. So don't install PDM as your project virtual environment. It should be installed in the global separately. So once you have this, you just say PDM dot init. It will create a projectory for you, and when you really do this init, it will ask you a few questions to try to understand what is that you are trying to do, which environment, Python environment. It will list all of them available to you, and you can select one of them, and once it is there, it will create the virtual environment automatically for you, and also it will support multiple backends. If you look at here, there are multiple backends, not one. You can support any one of them, you can use any one of them. It will ask for you license, you authors and all of them, and it creates you everything like virtual environment for you, git ignore, readme, project, like project toml, pyproject.toml, test source, all this structure will be created for you. So source is nothing, I think it will just be there. And look at this is the pyproject toml it's created, and it has name, version, everything that is there. Dependency is empty because you have not installed any packages as of now. And then the remaining build system, whatever that you have selected, it is there. PDM backend and PDM backend is there here. So this is created automatically for you. And then once this is there, next one is to, you have the project created now. Now the next is to really install some of the packages. You can say PDM add and then give the packages. So one of the good thing about all these things is they have a good resolvers, package, resolves, right? All the dependency resolution will be done by these things. So when I try to install the request here, it's going and fetching all of them. In case if there is a conflict of any of these packages, it will stop here. It will not really install it. It will not proceed. So what you need to do is there are some overrides. If you know that this is really going to work and it's okay, you can override and then install it. But at least it will tell you there is a conflict and you cannot really proceed, creating this. Okay. And then it gets installed, all of them installed it, and then you can again go back and look at the pyproject.toml after this, and you see this, like you have dependencies already listed here in this. So, and what I'll do is actually maybe it's really coming up. Sometimes it's a little slow here. Sorry. No. Okay. Okay, I think I'll just maybe stop here. This one. I'll go back. I think I took summary there. Okay, so there is a new tool in the town. I think I learned this only yesterday when I was talking to Anand yes, from Gravinar. I think he mentioned that there is something which is interesting. I just wanted to see, so there is a 10 to 100x faster than pip. Do you really want to know about what is this tool? Oh, you guessed it right. Very good. So UV is, the Python package, it is actually a little one step above it. Really, you can even install the Python, installable, and then it's just one installable. You can download, which is really, prepared in the Rust, using Rust. It is written in Rust, and a single tool to replace all the sensor. Okay. You can go back and refer it. Probably it's a homework for you if you want to go and look at. I think there is a very good thing, and I explored it actually yesterday night itself, and it's really, really fast. These are all the references that I really have. If it is there, I think I mentioned even in the tiny URL, you can go look at it. In summary, if you are still in a legacy using dish details, I think it's time for you to really definitely move on because it's been removed out of it. And also, I strongly recommend to really migrate to pyproject.toml. Don't use setup.py. I think use any one of the tools whichever you really like it. It's that there's no recommendation from me saying that use this one. But obviously, it's really worth exploring UV at this point of time. And provide as much of metadata about your project, including license, readme, and everything when you are publishing the packages. And if you are publishing a test packages, please make sure you publish to test PI, not to the PyPI. And PEPs are very, very helpful. And then reference links, I think, are going to give you a lot of information, which I have used it for preparing this talk. Thank you.
Yeah.